Hello everyone. So next topic is dropout regularization. So this dropout regularization is another regularization technique which we'll be using in order to reduce the weights so that we can reduce the costs. As you can see in the figure where you can see that there are four inputs, okay, which you can see x1, x2, x3, and x4. So these four inputs are given to the different hidden layers. So this is the hidden layer 1, and this is the hidden layer 2, this is the hidden layer 3, and the output layer. Okay. Now, with the dropout, we are going through each of the layer of the network and get some probability of eliminating the node in neural network. Let's say we are going to each node and have 0.5 chance of keeping the node. So let me keep this as 0.5. This also is 0.5 and this also is 0.5. Okay, that is nothing but we are having keep node as 0.5, which means 50% of the nodes are being removed. After you give the input to the network, okay, we see that one of the that is node will be skipped. That is, you can see that two of the nodes are being skipped. That is, once we are setting this to 0.5, okay, that is two of the four nodes are being cancelled out. Here also two of this cancellation is nothing but the dropping out, or you can say the removing the connection from the input to these nodes. Now, after remove all the ingoing uh, and outgoing to the node, so you get in this way. So at that point in time, you can see that we end up with the much smaller diminished network. And then you can do the Bragg propagation training with this example on this diminished network. Now, in each training example, you see that you drop different set of nodes. It's not that every iteration will be dropping these nodes only. On some nodes, you will be dropping other set of nodes. So here, in general, okay, you will be having a smaller network that are being trained by regularization that is dropping out the unused nodes. Okay, so here you can say this is the unused, this is the unused. So all these unused nodes are being dropped. Okay, and as a result, you see that the amount of weights, okay, utilized will also be reduced. Now, what do you think is that why this how whether this the uh, will work out? Okay, this dropout workout. So the intuition here is that it can't rely on one feature. So it has to spread out to other weights also. And the second intuition here is what this unit has to take an input and produce a meaningful output. Okay. So with the dropout, the inputs can be randomly eliminated where those units will be dropped or removed. Okay. So this by spreading out the weight, this will tend to have any effect, okay, on shrinking the square norms of the weight. Similar to what we saw in the L2 regularization, the effect of implementing the dropout shrinks the weights. This L2 regularization helps prevent overfitting. So dropout regularization as well as the L2 regularization both have the same effect, that is shrinking out, okay, the weights and preventing the overfitting. Now let's take the another example where we can see that a network with three input features, that is x1, x2, and x3. Now you can see that, okay, the keep outs which we are having is, okay, we are setting for different hidden layers. Now, in this case, you can see that the first hidden layer, there are 7 hidden units. Second hidden layer has 7 hidden units. Third has 3, fourth has 2, and the final has 1. Now, for each, okay, we decide what is the keep out. So, you can see that for the first hidden layer, that is the weights applied over here. Okay, weights applied to all these things. Okay, for this one and for this one. Okay, so for W1, okay, the matrix is 3 into 7. That is nothing but there are 3 inputs and 7 outputs. Okay, so 3 inputs and 7 outputs. Okay, and for the second, we say it as 7 inputs and 7 outputs. Okay, 7 inputs and 7 outputs. And for third one, it is 7 into 3. That is 7 inputs, 3 outputs. And for fourth one, it is 3 inputs, 2 outputs. And for fifth one, it is 2 input, 1 out. So you can say that the first one is 3 into 7 matrix. Second one is 7 into 7 matrix. Third one is 7 into 3 matrix. Fourth one is 3 into 2 matrix. And fifth one is 2 into 1 matrix. From the observation, you can see that the 7 into 7 matrix is overfitting. Overfitting in nature. Okay. So W2 is the biggest weight matrix, which is nothing but 7 into 7. Now to reduce the overfitting, okay, you need to keep the make the keep out. Okay, you can say keep prob, sorry, a keep prob to okay some relatively low value. So we can say that for first one, I am keeping the keep prob value as 0.7. For this, I am 0.5. For this, 0.7. For this 1.0 and 1.0. Now we can keep high keep prob values for the lower sparse matrices, but for the denser matrices, we can keep a higher value. Okay, because the denser matrix, the chances of overfitting is more, but whereas the sparse matrix, the overfitting is very less. Okay, now here you can see that we are dropping out 50% of the nodes in this case. Okay, so we are removing most of the nodes in the second hidden layer, and thus okay, we can have a very uh, smaller network. Okay, we can have a very sparse network. The smaller network we can have. Okay, now this also has the same effect like what we had shown in the previous example. Okay, and here also we see that by penalizing the weights, we can have the reduced costs. So this is about dropout regularization. Okay, thank you.